Thank you, Sarah. Thank you, Monica. Thank you, Augustina, for letting me speak today. I'm Mary Collins Chebib. I've worked in GABA receptors for 30 years. I'm the head of School of Medical Sciences at the University of Sydney, and I'm part of the Australian-Danish collaboration. So we all know that inhibitory and excitatory neurotransmitters, GABA and glutamate, play a major role in maintaining brain homeostasis. So if you tip the balance, things go wrong. So when this brain homeostasis is disrupted, then that tipped balance could be either way. You can have less inhibition, that is, not enough GABA effects. And you can see here that, no, it doesn't work, oops. You can see here it goes from being normal to being more aroused, and epilepsy. We know that epilepsy can be treated with pharmacological drugs, and as a result we know that if we increase the amount of GABA inhibition, that actually helps. But if you go the other way, if you have more inhibition, then this is on a normal person. If you have more inhibition in a normal person, it goes to coma and death. And the example is Michael Jackson. He died of having too much inhibition, but his brain was normal. So what happens when you have a variant? So for a long time, there's a consensus that GABA variants were all loss of function. And that makes sense, because if you don't have enough inhibition, it does cause epilepsy. And the consensus, even in 2021, is that all mutations to different extents reduced GABA-A receptor channel function, and the basis for the severity of epilepsy phenotypes with the mutations is likely related to the extent of reduction of receptor function. However, if we look at the patient phenotype, and they fall into a continuum, you can have variants in GABA receptors with no epilepsy, no effect. The brain still acts normal. Or you have a little bit of epilepsy. It's not severe. Or you can go all the way up to severe epilepsy with comorbidities. And clinicians, neurologists, can actually group them into distinct phenotypes. And it doesn't mean they're clearly distinct. There may be some overlap. So if we just separate these phenotypes in GABA variants, and we can actually distinguish them. If we look at, say, the first group, this group has febrile seizures or febrile seizures plus. They tend to have the age of onset of 12 months or more. They do have seizures resulting of temperature, so febrile. Developmental delay is normal. There's no psychiatric issues, and they're ambulant. The next severity is genetic generalized epilepsy to Dravet-like, and this occurs really around 6 months or more. Remember, it's not exact science, it's approximate. There is some febrile seizures, developmental delay is moderate to mild, there's no psychiatric issues, and ambulant might be delayed a bit. And as we become more severe with the developmental epileptic encephalopathies, it lasts even earlier, 3 months or 12 months. It's rarely febrile seizures. There's moderate to severe developmental delay. There are psychiatric issues, and they start to become non-ambulant, such as hypotonia. And finally, where we have the most severe cases, where they occur from 0 to 3 months, there's no febrile seizures, moderate to severe developmental delay, severe to profound developmental delay. They do have psychiatric issues, and they're non-ambulant and dystonia, and you can see that from Madeleine before. So how can all of these divergence originate from a similar functional loss of function outcome? So what I'll be showing you is that this old paradigm for variance is at best incomplete. We could have epilepsy with loss of functions, and we do see epilepsy with gain of function. And what I mean by gain of function is if we look at GABA, the effect of GABA on its GABA-A receptors, it pushes this curve that you can see in the green to the left. That means you don't need a lot of GABA to have an effect. And if you have loss, you're losing the effect of GABA, and that's the red. So we started with the gain of function, and what actually alluded us to this was, I recall sitting with Nathan, we were starting to work on these variants, and we saw a variant that was published by a group at the Westmead Children's Hospital in Sydney, and they were part of the University of Sydney.
And we went to talk to the clinicians there. And they started to talk about this little girl with the GABA-B3 variant, which was a glutamate 77 to lysine mutation, so E77K. She had infantile spasms. They started at 5 months. She was on a whole lot of medication. And because she had infantile spasms, they give her vigabatrin. But vigabatrin had a severe effect on this child, so much so that they had to take it away. This epilepsy was okay with vigabatrin, but the comorbidities were worse. We then looked at each other and we said, surely, is that a gain of function? Is that real? There must be not a lot of them, but surely there must be some. So we looked, we tested, we saw that this particular variant had a gain of function. We looked for other possibilities, and there was the T287I that had the same effect. Vigabatrin was hypersensitive. They were removed from vigabatrin, and that was a gain of function. And then there was this last child, case 3, where it was a loss of function. And vigabatrin was good. No hypersensitivity to vigabatrin. So then what we did is thought, well, is this real? So we started to talk to Rebecca Moeller, because she, being in the Epilepsy Hospital Philadelphia, she had recruited a lot of patients, and she curated the data according to most recent epilepsy classifications. And what we were able to bring to the party was that we were able to look at the functional assessments at all of these receptors fairly quickly, not 5 months like Rebecca says, but around about 3 months maybe. Where is she there? So we collected the detailed electroclinical data for that large number of affected patients. We performed the functional analysis and performed extensive genotype-phenotype. And I think this collaboration has helped us to improve the field over the last 5 years very quickly. So I'm just going to give you a few highlights. So our very first large paper was published in Nature Com and in Brain, and we looked at these beta-3 variants, and we were able to classify these variants into both gain and loss of function. And we were able to see that the phenotype, DEE and EIDEE, etc., were the gain, so they were the most severe, and the loss of function, as you can see, had the febrile seizures and the Dravet-like. The next paper that we did was, and Nathan's going to talk in more detail, is that we looked at the beta-2 variants. And we published this variant. We looked at 26 presumed pathogenic variants. And from the data that we were able to correlate the phenotype, we were able to separate the gain of function variants. And we were able to separate them into a low shift gain, so slightly milder, to the high shift gain. And finally, this is a highlight from our Gamma-2 study, where a manuscript is under review. We mainly focused on loss of function patients in this paper, 19 null, that means they had a stop codon, and 12 missense, and 6 gain of function patients. And what we were able to see, and again Nathan will talk more in detail, is that we were able to separate the loss of functions, where the least severe are the null loss of function, followed by the missense loss of function. So where are we at? We have determined that genetic variants in GABA-A receptor subunits can lead to both gain as well as loss of function, and patient phenotypes correlate with functional analysis. And patients with gain of function variants are more severely affected. Different subunits have different brain distributions and therefore different specific phenotype outcomes. So where the variant may lie may affect what you see in the comorbidities. So what are we doing in the future? And you would have seen a similar slide from Rebecca, is that we're working towards a precision medicine approach for identifying treatments for patients. We already are doing a lot of genotype-phenotype for all the genes. We're working in collaboration with Dennis Lull to look at the portal. We're working with the Flory, so Chris and Pew, who you will see her talk later. We're looking at animal models and looking at the electrophysiology in slice. We're also working with the Danish group to look at human iPSCs, and of course we're looking with Rebecca to assess the standard of care drugs and negative modulators where needed. So this is leading towards personalised treatments for patients, and I want to highlight that Pew's talk is very exciting. It's unpublished data,
and she does a great job in presenting it. So I'd like to acknowledge both my collaborators, all of them here, most of them in Denmark or in Australia. I'd also like to thank the National Health and Medical Research Council of Australia for our funding, and also the Lundbeck Foundation program grant that we're on. And thank you for listening.